type of circuit arrangement that we're going to analyze is the parallel circuit. So to understand what the difference is, we should first think about what the term parallel means. And much like in geometry, it means side by side or two lines that never cross if you extend them, etc. So elements wired in parallel simply are wired not one right after the other, but one right next to the other, giving electrons essentially a choice. So in this case, electrons have multiple pathways to choose from, but they'll only pass through any one of those resistors. Kind of like toll booths on a highway where you choose which one you'd like to go through. You don't go through the other ones, you have plenty of choices, but you will only choose one. So to segue off of that, we have the toll booth analogy as it pertains to parallel arrangements. So if we want to charge cars $6 again, anytime they travel from point A to point B, well, if we have a parallel arrangement here, meaning side by side, we have to charge $6 at each, because even though there's two pathways, if we only charge $3 at each, we'd only make $3 per car, because despite there being two pathways, any car only passes through one of those lanes. So as cars come in, they choose whether they want the left or the rightmost lane, and then they continue on their way. And if we assume again that they started with $6 in total, before they approach these toll booths, they have $6. They have to spend the $6 to get through, and they'll leave the other side and arrive at their destination with $0. If we expanded and added another lane, we still have to charge $6 because despite the extra option, cars only go through any one lane. And once again, prior to choosing a lane, I'll have $6 in my wallet, and no matter which I choose, after I pay my toll and travel through, I will have $0. The same applies to circuit arrangement. If I'm traveling through, I'm going to have $6 before I enter those resistors. I have to spend, quote unquote, spend 6 volts or drop by 6 volts to get through, and I'll have 0 volts on the other side. So what we have to realize here is in a parallel circuit, there are multiple pathways, but the electrons only pass through any one resistor. And because of this, that means that as more and more resistors are added, the resistance actually decreases because you're giving more options. Think about it like the toll booth. If you only have 2 lanes open and traffic is getting backed up, they'll open more lanes and more cars can get through. Or think of the supermarket. If there's only 2 cashiers working and there's a line of 100 people, they will make a call for other people to open additional cashiers. If you think about it, those cashier stations are in parallel, so more people can get through. Give them more choices, more people can flow through. So in a weird way, adding resistors in parallel, because it adds more options and adds more branches that this battery has to fill up with electrons, it actually decreases the resistance because now there will be more current pumping through this circuit. So as we said, the current that the battery can supply increases because it has more branches to fill up. The other thing we need to realize is the voltage across each resistor is the same because no matter which pathway they travel through, they're only going through one resistor. It's like the toll booth analogy where no matter how many additional lanes you add, we still charge $6 because you're not adding more resistors electrons have to go through, you're adding more pathways the electrons can go through. So you apply the full voltage to all of these cases because no matter which pathway you choose, you're going to spend the full voltage because you're only going through one resistor. And the last thing we should realize here is it is the current that splits into each branch. Just like if you had 100 cars approaching this toll booth, they're going to split. 50 may go one direction, 50 may go to the other lane. It's the current that splits, but they're all going to pay the $6 as opposed to the series circuit in which all of the resistors have the same current, but it's the voltage that splits. So parallel and series circuits are kind of inverses of one another in terms of the concepts. So if, for example, you had 6 volts leaving this battery, assuming these resistors were identical, when you hit that location, the current will split. 3 amps may go down and 3 amps may continue on the right. When those two come back together at the bottom, they will recombine to give you 6 amps, much like if you had 50 cars choose one lane and 50 cars choose the other. After they merge back together onto the highway after the toll booth, you will have the original current, despite the fact that they split to go through those parallel pathways.